For the last part of the framework, we'll explore the diverse set of tools geared towards analysis and visualization. While data storage, cleaning, and transformation are all equally important aspects, analysis and visualization is where the tool landscape explodes. There's more possible options out there than we could ever possibly cover here, so we'll be picking a few key examples of each. Hello Excel, our old friend. There's a surprising amount you can do with this staple, both in analysis and visualization. In a later segment, we'll show you some surprising things you can do just in Excel. But Excel isn't on its own in this category. Here's where we add in the other half of this power duo, Visual Basic, or VBA. This is a programming language that Excel uses to help you write macros for automating tasks and even create your own custom formulas. Don't be thrown by the programming language part. What's great about Visual Basic is it has a graphical user interface, or GUI, that helps you put those macros and formulas together without having to actually learn the underlying programming language. It's beyond our scope in this course to get into detail about it here, but if you're needing to do the same repetitive things over and over in Excel, digging into VBA will make your analysis work much more streamlined. Tools like Amazon QuickSight and Tableau offer suggestions for visualizations based on the data you're working with, and most in this category have mobile apps as well for easy access and display of data and visualizations no matter where you are. Power BI goes a bit further with some data governance, security, user access roles, and other features that aren't necessarily included in applications geared primarily towards analysis and visualization alone. Socrata falls a bit in the middle, providing cloud-based analysis and visualization options specifically geared to government organizations, including controls and security, so the right people can easily access and use the appropriate data for their needs. Not long ago, SAS would have been relegated to the last slide for complex analysis needs. That was partly because it fell into the spectrum near programming languages, as it is one of the earliest languages developed specifically for data analysis activities. There's now a graphical user interface product called SAS Visual Data Discovery, which brings it toward the realm of Tableau, Power BI, and the like. That said, it's still a bit clunkier and doesn't have quite the same ease of use as newer, more modern applications. Ultimately, however, it's still an incredibly powerful tool that can handle very large data sets and complex analyses and visualizations. Also in the same general zone is ArcGIS, which provides analysis and visualizations of geographic data. Maps are some incredibly powerful visualizations, as we saw in our course on that topic, but they're also often large and complex sets of data. ArcGIS does have some basic canned mapping features that nearly anyone can use, but the real power of this tool is in handling and combining multidimensional geographic and demographic data. Now we've reached the most powerful set of tools, which all happen to also be free. And as you may have already started to notice, there's a trade-off between free and paid products and the amount of support and services included. If you have the time and ability, you can manage just about any level of complexity with programming languages like R, Python, or Julia, all of which come highly regarded by people whose primary job is data analysis. But there's no service line you can call or email address at the waiting. Now, of course, you're not isolated. There's tons of online learning resources and communities dedicated to these languages, and there's also plenty of libraries, the code kind, not your book kind, to help bootstrap all kinds of programming-related efforts. But this approach presumes you or someone in your organization has at least some familiarity with programming concepts and the time to learn and experiment. We've included Jupyter here as well, which is a web application that allows you to create and share documents, also known as notebooks, that contain live code, equations, visualizations, and narrative text. Programming experience is also required to create Jupyter notebooks. There is undoubtedly some tool or language that we didn't cover here. We wish we had time, but we're not sure when this course would end if that was the case. What's important is to give you a framework within which you can now place new tools or options as you encounter them. That said, there is one elephant in this room, and it's this one. Inevitably, spend enough time in data analysis or data science circles, and Hadoop is going to come up. Hadoop is an open source software framework for storing data and running applications on multiple groups of servers, also known as distributed computing. It provides massive storage for any kind of data, enormous processing power, and the ability to handle virtually limitless concurrent tasks or jobs. If that alone doesn't convince you that you probably don't need it, consider that most organizations using Hadoop are processing massive amounts of accumulated data. For example, Google, Facebook, financial institutions, in Fortune Top 50 companies. It also requires clusters of servers and employees with specialized programming and data management skills. In the case of choosing the right tool for the job, Hadoop for most government organizations would be like bringing a backhoe to a community pea patch. Or perhaps using a hammer on a screw. Regardless, if you come away from this with just one thing, it should be picking the right tool for the job. And sometimes the simplest tool is the best one.